These are the 3.9 notes for Algebra 2. This is all about simplifying and solving with imaginary numbers. So you notice all of these have a negative underneath the square root, which we're normally not allowed to do. However, what we're going to do is we are going to simplify these like normal, ignoring the negative at the beginning. Create a factor tree. Remember that pairs go on the outside and any singles go on the inside. So I have a pair of 3s and I have a single 3 and I also have a negative. At the very beginning I had this as a negative 27. Anytime I have a negative, I'm going to put an I on the problem. I like to put the I right after the pair of numbers and before the square root. So your answer for that would be 3i radical 3. For part B, 16 is a perfect square, so we don't have to make a factor tree for this. The square root of 16 is 4, and because I have a negative right here, I'm going to put an I. 4i. Part C, take 56 and break it into two things that multiply. I'm going to do 8 times 7. 7 is a prime number, so that's done. I'm going to break up 8 into 4 times 2. Then break up 4 into 2 times 2. Remember, we don't want to look at any of the numbers that have already been broken down. So the 4 and the 8 are no longer useful to us. I have a pair of 2s right here. And then I have a single 2 and a single 7. Those two singles are going to go both inside and be multiplied. So I have my pair of 2s on the outside. I'm going to multiply 2 times 7, and that's what's going to give me my inside number. Also, because I have a negative, I'm going to put an I. So my final answer will look like 2i square root of 14. All right, part D. Break down 68. If you don't know numbers that go into some of these larger ones, you just grab your calculator and start dividing. So maybe divide by 2, then divide by 3, divide by 4. See if you can find a number that it goes into. I found 2 and 34. 34 then breaks up into 2 and 17. I have a pair of 2s right here. That goes on the outside. I have a single 17. That goes on the inside. And because I have a negative, I put an I right there. Part E is again a perfect square. So I don't have to make a factor tree out of it. I take the square root of 64 and I get 8. The negative means I put an I for imaginary. All right. For example number 2, we're going to be solving. You're going to solve these the same way we did the regular equations, but they're just going to have an I in it. So for part A, to get rid of this little square right here, we are going to square root both sides. That gets me x plus 2 equals, because the square root and the square cancel. And when we square root a number in an equation, we have to put a plus or minus sign. So plus minus 4i. Then you're going to subtract 2 from both sides, getting you x equals plus and minus 4i minus 2. That's actually 2 answers. You can write them separately if you choose. It would be a positive 4i minus 2 and then the negative 4i minus 2. So you could also split that up to be written as 2 separate answers. Part B, subtract 5 first. Bring down 2x squared You get negative 80 here. And we want to make sure we get rid of this regular number 2 in front before we square root anything. So I'm going to divide by 2. Now I'm ready to square root, so I'll square root both sides. 40 is not a perfect square, so what we'll do is we'll need to make a factor tree out of it. I'm going to break mine into 4 and 10. 4 breaks into 2 and 2. 10 breaks into 2 and 5. So I have a pair of 2's, a single 2, and a single 5. And remember that if we have more than one single number, we multiply those together. So over here, I'll write a plus or minus sign. So don't forget plus or minus. Let's write a note about that. We'll have 2 square root of, and then you're going to multiply 2 times 5 to make 10. And because you had a negative on the 40, you are going to squeeze an I on there. You could also write this as 2 separate answers. You can write it as the positive version, and you could write it as the negative version. Part C. We're going to start by dividing out the 4. Bring down x minus 3 squared. I'll divide the negative 100 by 4 to get negative 25. Now it's time for me to square root. The square root and the square will cancel. And that will leave me with the x minus 3. I no longer need those parentheses anymore, so I'll just leave them off. And then 25 is again a perfect square. Don't forget the plus minus sign. The square root of 25 is 5, and the negative means it's an I. Our last step here is to add 3 to both sides. You cannot actually add 3 to the 5i because those are unlike terms. So just like we did on the problem part A, we'll write them separately. 5i plus 3. You could write that as 2 separate answers if you want, or you could just leave it as the one. Part D, add 5. I'm going to put a negative 1 in front of that x squared here. 7 plus 5 is 12. And I'm going to divide by negative 1. This gives me x squared equals negative 12. Now it's time for me to square root it. "12 is not a perfect square, so we'll need to come off to the side and make a factor tree. You're looking for a pair of numbers that multiply to 12. The first one I think of is 2 times 6. You'll get the same factor tree if you choose 3 and 4 as well. And 3 times 2 is 6. Remember that our pairs go on the outside, so I have a pair of 2's right here. And I have a single 3. A couple things to remember. Plus or minus sign anytime you're solving with a square root. You have the pair of 2's, which is represented by that 2 right there. You have square root of 3, the single number, goes on the inside of the square root bar. And then because the 12 was originally a negative, you're going to squeeze an I right there. There we go. We're going to practice 2 quadratic formula problems. These, again, work the same way as the regular quadratic formula problems. They just will have a negative underneath the square root. In order to do the quadratic formula, let's go ahead and write it out over here so we have it. X equals negative b plus and minus b squared minus 4 times a times c, all divided by 2a. Our first step will be to identify what is a, what is b, and what is c for this problem. All right, a is going to be the number in front of the x squared, 1. B is the number in front of the x, which is negative 6. Don't forget the sign, the negative. And then c is 25. Once you've identified those, you can plug them into your quadratic formula. X equals just means the answer is going to be negative b, so negative 6. You have the negative from this part right here as well as the negative from there. Plus and minus sign. B squared. Now, it's a good idea here to put that b in parentheses, especially if it's a negative. 4, and I like to put these in parentheses too, times a times c. Then in the denominator, we have 2. This is always a number 2, times our a value for this problem, which is 1. After that, you simplify. So you're going to work underneath the square root bar, which is called the discriminant. I'm going to end up with a positive 6 on the outside. And then type this into your calculator or use very careful mental math in order to figure that out. So I'm going to type this into my calculator. Everything I see under the square root bar, I'm going to type it in. As I do that, I get negative 64. Then 2 times 1 in the denominator is 2. I'm going to still focus on the discriminant, so what's underneath the square root bar? The square root of 64. 64 is a perfect square. So I know the answer is 8. Because of the negative, I will put an I. That's a pretty good answer. There is one thing I notice about that problem, though. I notice that all of these numbers can be divided by 2. So now I want to reduce this. And I want to reduce it by 2. So I'm going to take each of these numbers, 6, 8i, and 2, and I'll divide them all by 2. 6 divided by 2 gets me 3. 8i divided by 2 gets me 4i. And 2 divided by 2 is 1. Most of the time in math, we do not write a 1 underneath a fraction. So the best way to write your answer is 3 plus and minus 4i. One more problem to go. We'll start by identifying our A, B, and C. A will be 1. B will be negative 3. And C will be 10. We'll very carefully plug these numbers into the quadratic formula. Negative b, which again is going to be a double negative, plus and minus the square root. Use a parenthesis to do the b squared, minus 4, that 4 is always there, it's part of the equation, times a times c. All divided by 2 times a. For our problem, a is 1. Now it's time to plug this into our calculator or do it very carefully. Again, into your calculator, you would do negative 3 squared minus 4 times 1 times 10. If you don't have a calculator available, that's okay. You can do each of these parts separately and then subtract them. Negative 3 squared is 9. 4 times 1 times 10 is 40. So even without a calculator, you can still figure out that answer. All right, so let's pick up the rest of the problem. I've got 3. This double negative turned positive. Bring down the plus or minus sign. And then 9 minus 40, that answer is going to be negative 36. That's what goes underneath my square root bar. And then in the denominator, 2 times 1 is 2. "36 is another perfect square. So you don't have to make a factor tree for this one. The square root of 36 is 6. Because it has the negative on the 36, you need to put an I on your answer for imaginary. And then bring over the 2. Now, this one is not able to be reduced. 3 and 6 have something in common, but the 2 would not. So 2, 3, and 6 are as low as I can get these problems to be. So that's going to be my final answer. No reducing on that problem.